the different taste and intent models that you have attributed to the customer. There are these steps. You first create a micro segment. You say that, okay, I'm interested in selecting people who have shown strong affinity to a certain brand. So you create a micro segment, analyze its characteristics, and you can iteratively refine these segment definitions to match your needs. So what's really unique about this particular kind of workbench is that prior to this, some of you who may have been exposed to analytics workbenches and BI systems in large organizations, to create a segment takes hours of effort, and that's what turns business users off, right? If I want to create a certain segment and want to study its properties, you cannot say that, okay, I'll give you a query and then you come up with the segment after 5 hours, and then more often than not, that segment will be wrong, right? It won't be what I initially desired. So if I want to change certain fields in that definition, I'll take another 5 hours. So that is not done. So how do you cut the cycle and leverage big data technologies to really deliver such research, so enable consumer research in real time? And that is what these platforms are about. I'll take one story and a couple of brief examples of how this platform can be used. Let's say a marketing campaign that we are launching for a brand called Asics, which is into sports shoes, and I want to send an email campaign to a list of users who may be interested in this product. Now, what I do is I come to this platform, I create a target group for this particular campaign. The definition being that select all those customers who you think has a high affinity towards Asics in sports shoes, right? Simple. And it returns the cohort, and you see that, okay, there are 3,876 such customers that you have found who have shown a certain level of affinity. Now, my marketing campaign at least needs to go out to around 1 lakh users, if not less. So what do? I can change the definition here to select customers with lesser affinity, or I study what is it about this set of 3,800 people which really sets them apart. Analyze that and create a different query, right? So over here I can see that all of these people, they tend to purchase sports shoes greater than 4,500 in price. So it's kind of a premium brand is what I make of it. And so I get to this point that perhaps we can find other customers who are not showing affinity to Asics as of now, but maybe purchasing other brands which are really pricey in sports shoes. So let's take Nike. We have a lot of Nike customers. It's being a more established brand. And can we select people who are purchasing premium Nike shoes? And I land up with many of them, so I'm happy, and I can get a decently large target group for my campaign. So this is the kind of this presents you the power of an analytics workbench if you can enable iterative customer research through that, right? So another use case, very briefly, how preferences. So this is important for a product designer. Let's say I'm launching a certain women dress collection. I want to see what kind of neck patterns are being preferred in a certain price range. So I've made up my mind that I'll only focus on premium women customers. So what kind of neck patterns do they wear? And I have a similar query that I run, and I get a list of customers, and now I can really study the properties of what is it that sets this set of customers apart from an average user at Myntra. And we have dashboards that help us give such insights. Okay. So architecture, I think I'm not running out of time, but I can take questions on that architecture. It's fairly detailed, so for the technically motivated, I'm happy to take questions on this. But at a very high level, let me try to summarize this. So what's happening is people are surfing on Myntra.com. That's firing many events. So any click that you do fires an event that goes and gets aggregated. We use Amazon infrastructure to store our event logs, and they need to be aggregated so that different cuts of that data can be retrieved efficiently. So we have different aggregators. Most of these are batch pipelines, ETL, and we use Cassandra to store different aggregated cuts. So for example, for a particular customer, all his clicks are aggregated, and I can just enter a user ID and very fast retrieve all his click stream. So that gets stored in storage like Cassandra. We have different models that I talked about, taste models, intent models, which run on a regular basis, again in batch, on this particular Cassandra system. And we mine profiles of those customers, which get stored into, again, different kinds of databases that support different workloads. For certain application-led workloads, they are stored in Cassandra. For the analytics workbench piece that I showed, that's powered by a Mongo database where we stored the customer profiles. And then there are other data sources apart from click streams that's feeding into these storages. So we have the transactional history coming from transactional data warehouses. We have other product knowledge and graphs about products and other kinds of content that we are creating from other data sources, and that also feeds into our models. Okay, and finally, there are two variants of personalization. Most of it is nearline, which is like you will react in maybe 1 or 2 minutes, and some of them are online use cases. So I leave you with certain quotations about personal style, and you can read about them, and after you read about them, you will definitely think that I was kidding all this time, and I don't know anything about personalized style. If these are the people who know what personalized style is, a data scientist definitely cannot. So thank you. We have a blog going. You can read our blog to get to the latest stuff that we are discovering.
Right, so I think many thanks, Devdut. We'd like to felicitate you for your contribution.
Thank you.
That's you. Thank you. Thank you. Thank you so much.
Thanks.
Okay. All right. Thank you. Right, so once again, in the best interest of time, let's have our final presentation now, and post that perhaps we can all break for tea and coffee. So, and secondly, also the final speaker, Mr. Machaya, has got a flight to catch to Mumbai, and as a result needs to conclude his presentation ahead of time considering the Bangalore traffic conditions. So can we have you here, Mr. Machaya?
So I think I'm coming in between, I think, Friday evening traffic and talking about health and wellness. Let me give you a little bit of context. Who am I? Lived in the US about 19 years, came back to Bangalore 6 years ago, and fundamentally started looking at technologies which would change people's lives, and what I call purposeful technology. So what I'm going to talk about today is a startup which we are in the process of launching. It's about 2 years worth of work. And it's a platform we have launched along with Deepak Chopra. I don't know if people know Deepak Chopra, MD in the US. and a bunch of well-known, I would say, physicians, doctors, scientists. And what I'm going to talk about today is the framework. I think the data scientists before me probably talked a lot about analytics. But I'll tell you what we are doing and why it's probably relevant to India. And then I would love to get your thoughts and perspectives on this. Firstly, Bangalore is the city I grew up in. Bangalore is home to me. I grew up in Bangalore, went to school in Joseph's. I left India in 1991. Very interesting, when I read the newspaper this morning, it says Bangalore is now turning into a suicide capital. Not something as a Bangalorean, my hometown was Coorg, right? Bangalore is a retirement capital, retirement city. It is the garden city of India. How did Bangalore, Namma Uru Bengaluru, become a suicide capital, right? Very interesting, very disturbing, right? So this is something which we've been looking at over the last 2 years, looking at urbanization and what's happening in our cities and what can we do about it. So alarming rate of growth. And the number one reason, if you really look at it, is stress. People today are stressed more than ever, right? Lifestyle disorder, sleep is number one problem. Today, if you look at a city like Bangalore, we have people from all over India coming in, from Chhattisgarh, Bhubaneswar, all parts of the world. We are designed to live in a community. We are designed to live like a village. But we are now we are connected with WhatsApp, Tinder, Google+, Snapchat, you name the messenger, we got it. But the only problem, we're still very lonely. So this is an interesting trend. So I'll talk about what this means to big data. For me, big data should solve simple problems, not complex problems. Big data should solve problems like, am I lonely? Am I stressed? Am I anxious? Am I in love? Right? Can big data transform people's lives? That is really the crux of the problem. So when we started looking at this problem with Deepak and the team in the US, we said, what can we do in India? And what can we do for the villages and the rural India? And then how does big data play a role in this? So I'll give you kind of a snippet. So I kind of spoke about this sleep and stress, number one killer. More stress, lack of sleep, cholesterol goes up, cortisol levels goes up, all the different problems with hormone imbalances, huge health problem. Second thing, Bangalore is also called the wheezing capital of India and the sneezing capital of India. High incidence of asthma. You all better go home really fast. Don't listen to me actually, it's not a good idea. Because in the next 1 hour, if you are smoking, you're really screwed, right? Because even without smoking, the pollution is killing us. And if you look at when I moved back here, I have a 10-year-old son and a 14-year-old son. My 14-year-old is a golfer. And his biggest challenge after moving back to Bangalore is asthma, right? I have to look at days, time, hours, and what is the asthma pollen level count in a city like Bangalore. So these are very, very important things, and this is the area where big data can play a very, very important role. And this is an area which the company is called Geo means live, right? So our goal is to basically give people a chance to improve their quality of lives. There are a lot of different applications of big data, but our very focused application, can big data change personal health? In the process of changing personal health, change societal health, and in societal health, we as a country can be better, right? If the 50 people in this room are happy, the 100 people around us are happy, and then as a city, we are happy, right? So that's really the goal, what Geo is after. It's a big task, but we believe this is something we want to take on, right? So why do we believe this air pollution data is quite important and all that? There's something called particulate 2.5, and I'll email people all the information. Today, if you really look at the data over here, anything less than 10 microns, is basically affecting your lung function, cardiovascular diseases, allergens, huge impact, right? So what does this mean? So I'll come back to the point. So what we are doing with big data is looking at data very differently and really creating this concept of awareness, to bring awareness to people, right? So what does this mean? So what we looked at is the hard problem. So typically we said, okay, stress and anxiety is a huge problem, right? So how do you understand if people are stressed? Can we use analytics and big data to predict stress, right? Can we understand when people are stressed, what can we do about it? So this is some of the technology. I'll give you a glimpse of what we are trying to do. So typically we go to let's say you're stressed, you have issues with your marriage or whatever, you go to a psychiatrist or the therapist, right? Niemann's, very, very appropriate, good setting. First thing, you go to the therapist. The doctor will say, hello, how are you? Sit down. What's your problem? Marriage, breathing, chest breathing, deep breathing, shallow breathing. They look at your breathing pattern. Your breathing has a very interesting correlation into what's going on. Today we have sensors which can measure breathing. Spire, read about it, very good. Second thing they look at is, hey, talk about your marriage. Marriage, 20 years, wife problem, whatever problem, right? They look at your face. It's called micro expressions on your face. The 16 micro expressions which we can now read. Everybody uploads selfies on the internet, right? Perfect analysis, image analysis data. We can actually now go back, analyze your pictures on the internet, and now go back and say, what is your mood change over a period of time? The second thing, look at your eye, the variegate fold, drooped eyelid, signs of depression, right? The third thing they do, they look at your skin, sweating, hydration, dry skin, what's your skin like? That's, once again, anxiety, right? Galvanic skin response, skin conductance, we can measure that, right? The last thing they look at is your posture, gait. What is your, what are you doing? You have accelerometers. People have Jawbone, Fitbit, phone, whatever, everything has. I have a phone in my pocket. As I speak right now, it understands my low-level functions, walking, sleeping, dancing, running, swimming, whatever, right? So now if I combine all the four parameters, I can pretty accurately figure out what is the state of my mind right now, right? So what we started doing is saying that this phone can pretty much, if the phone could actually speak, a lot of marriages would be in trouble, right? A lot of girlfriends, boyfriends would be in trouble too, because the voice never lies. Voice modulation, right? Stress, voice signatures. So what we started doing was saying, forget about wearables. Wearables is a very affluent thing, right? Who's going to wear a wearable? How many people here have wearables? One, perfect. I have one wearable because I have to wear it. But everybody else has a smartphone? Everybody here will have a smartphone. So can we build this technology into smartphones? So that's what we embarked on. So what we are doing today is basically what we call personal biohacking, right? Can we use the smartphone to pretty much replicate my mother, right? My mother, if I left in the morning, they would say, you know what, drink orange juice. Because I'm from Cook, oranges were at that time quite common, oranges all year round, drink orange juice, right? So we start basically saying, can we create, have you seen the movie Her, H-E-R, Her? Yeah, Joaquin Phoenix, and wonderful movie. People haven't watched it. It's a pretty disturbing movie, but this guy falls in love with his computer, right? It's like Siri. It's called the operating system. We are not very far away from it, by the way. Our phone actually knows us better than anybody else today. The way I type, the way I browse, the way I send messages, the way I answer the phone, what I do every day, it knows. I might forget my wallet, but if I forget my phone, I'm going back home, right? I will never leave my phone back home, especially without a password. Very important, thumbprint and all that, right? Everybody does that, right? Nobody keeps the phone unlocked. Okay, good. So what I started doing was looking at wearables. We looked at all the different wearables, and this is common knowledge. You guys know about this. Everything from the head to the toe is being mapped. I can study pretty much, especially looking at some of the wearables coming out over the next 5 years. There'll be about 100 sensors around us, ambient, whether you like it or not, measuring everything, right? So it's a given that I can do a much better job than what most doctors can do. In fact, there's an interesting book, and he's one of our advisors, Eric Topol from Scripps, Digital Medicine, Steven Steinhubble, who basically talks about the creative destruction of medicine, right? Because when you go to a doctor, they'll say, okay, what happened? How are you feeling? Doctor, I went yesterday, I had a cold, I ate an ice cream, right? That's probably my perspective. But imagine I could just go back and play back the day, and now it's my phone, right? Imagine on this platform, I give the doctor a background record. Punasha woke up at 4:30 in the morning, he went to the office in Indiranagar. After that, he basically went to Cafe Coffee Day. After Cafe Day, Coffee Day, he went into, the ice cream place. It actually knows my lat long. So what we're doing today is the concept of event logging, life event logging. So you're taking a low-level function, which is what we call walking, jogging, cycling, walking and all that, to a high-level life event, which is going to office, going to a birthday, going to a wedding, going to a coffee shop, having dinner. We're combining a low-level event with a high-level event, and now looking at correlation causation on the data. So apps have come out. This is what I call the 2.0 of quantified self, which is mostly giving context. Everything from your genetics to sleep to breathing to how much water you drink can be now has an app for it.